Hello everyone, welcome to the series of PYQ solutions of CSAT paper. In this we have done 2024 CSAT paper. Now we are into the 2023 CSAT paper. So let me download the paper straight away from UPSC website. So previous question papers. Yeah. So in this previous question we are going to 2023. Yes, paper. So we'll go to this paper directly. And again, as we have seen earlier, we'll look into mainly the logical reasoning and the quantitative aptitude questions. And in this one, I'll take just some privilege to run a bit faster in the concepts where you are aware, like what we have done in the 2024's paper. Like I will try to run faster in those questions, like the similar questions. I'll try to run faster. Very important, and the new topics again there. I'll try to explain the concept. Let us look at the paper now. Here, fourth question is our area of interest. So here, this is a quantitative aptitude question. This is related to the permutation and combination or related question. Let us check the question. Raj has 10 pairs of red, 9 pairs of white and 8 pairs of black shoes in a box. Pairs. When I say 10 pairs, there are 20. When I say 9, there are 18. And when I say 8 pairs, there are 16 shoes. So if he randomly picks shoes one by one without replacement from the box to get a red pair of shoes to wear, what is the maximum number of attempts? Maximum number of attempts he has to make. See, here in this case, we have to think of the worst case. So here 20 red, 18 white and 16 black shoes. So totally there are 54 shoes. There are totally 54 shoes and he has to pick red. So 2 red shoes have to come out of that box. So basically, for the luckiest person, first 2 shoes themselves are like red. So that is one thing. But again here, at the worst case, how many attempts, maximum number of attempts that we have to make? So for the unluckiest person, all the picks that he do for the first 34 times, like they'll be either white or black. Red is not coming at all. Red is there in the box. None of the red shoes is coming out. So in that case, 34 attempts he has to make. 35th will be red for sure, and 36th shoe will be red for sure. So this is what we have to do. Here we have to assure that in how many attempts we are going to get the red at the worst case also. So we have to make 36 attempts to get a pair of red shoes. It's a simple, no calculation, nothing there. Like we have to think from the worst angle. So when red is in the box 8 and all the white and black shoes have come out, so only red are remaining. So you need to 34 are other colors, 35th and 36th will be red. Fifth question. In how many ways a batsman score exactly 25 runs by scoring single runs, 4s and 6s only? See, this is a bigger problem because to get 25 runs, practically, you have n number of ways. So we have to find those n number of ways. For that, I'll tell you a method. First, you have to think of 6, then you have to think of 4, then you have to think of a single. So in such case, always you have to write either in the decreasing order of the units or increasing order of the units. In this case, you have to start with 0, 0 in the first 2 columns. Now, if he wants to score everything by singles only, there are 25 singles. Then slowly you have to take this as 1, 4. In that case, he will have to score 21 singles. Now you should not think of 6s at all, only 4s. So how many 4s he can hit out of 25 runs, 4 6 are 24. 4 6 are 24 and one single. This is one way of calculating. Without any 6, like how many ways he can score? 25. So 0 to 6. So 7 ways. So similarly, when I come to the other calculations, now I'll go with 1 6. I'll go with 1 6 and 0 fours. Now I need 19 singles. Now 1 6 1 4. So I'll fix with 1 6 only. 1 6 1 4. So he would require another 15 runs. Now 1 6 2 fours. Then he would require 11. Like this, like he will hit 1 6 and 1 6 and 3 fours will get us 18. So 1 6 and 4 fours, 22 runs. So 3. So 0 1 2 3 4. So 5 ways. 5 ways he will hit. Next. So 6 4 1. Now I will take 2 sixes. 2 sixes and without any 4, 13. Then 1 4 9. 2 fours. Then 5. 3 fours. Then 1. So like this, 4 ways totally. 4 ways with 2 sixes around. Then we have 3 sixes, 0 fours, 7 runs. 3 sixes, 1 4, 3 runs. This is 2 ways. Now he will hit 4 sixes and 0 fours and 1 single run. So this is 1 way. So 1 plus 2 plus 4 plus 5 plus 7. So that is totally 19 ways of scoring. This is time consuming but doable. It is a time consuming, you should know. And what is the trick here? You have to arrange the units 6, 4, 1 or whatever might be the unit in either ascending order or a descending order. And you have to start with 0. You have to start with the minimum unit, like maximum number of minimum units. So 6 and 4s are 0. Then slowly you are coming to 1 4, 2 4s like that without any 6. Then with 1 6 all combinations. With 2 6s all combinations. With 3 6s all combinations. If you do like that, maximum number of 6s that he can hit is 4. Then with that we have one single run. Like that you have to do. And we don't have a formula to get the answer for such questions. You have to work in the examination but with a method. Here ascending order or descending order, initially you have to take the bigger units as 0 and the smallest unit as n number. Then you have to proceed. Next question. This is a bit tougher, I would say, or this requires a different set of skills. 4 letters and 4 envelopes, and exactly there are 4 letters and 4 envelopes. Exactly one letter is to be put in exactly one envelope with the correct address. So 4 letters are there and 4 envelopes. So one particular letter has to go in the right envelope. Is to be put in exactly one envelope. Exactly one letter is to be put in exactly one envelope with the correct address. This is what is the demand. If the letters are randomly inserted into the envelopes, so there is a chance that there can be a mishap. Like one is going in another is going another. There is a chance like that. So many chances are there. Okay. Then we'll look into the statements. It is possible that exactly one letter goes into an incorrect envelope. See, there are 4 letters and 4 envelopes. Let's say A, B, C, D. A, B, C, D. These are the envelopes. And A, B, C, D. These are the letters. Let me think that we are disturbing one arrangement. Letter A is going into envelope B. Letter E is going to envelope B. What about B? It has to go somewhere because it is already occupied. So even B will get disturbed. So you cannot just disturb one. When you are disturbing one, at least other one will get disturbed. So it is possible that exactly one letter goes into an incorrect envelope. No. Minimum 2 disturbances will happen. That means if A goes into B, B has to go into A or C or D. So definitely there will be more number of disturbances. Next, there are only 6 ways in which only 2 letters can go into the correct envelopes. Here they want us to seek exactly 2 envelopes correctly. So I'll show you how. For example, like these are the envelopes A, B, C and D, and their respective letters are A, B, C, D. So here they are asking, they want only to be correct. So A is going into A, B is going into B. So now they want to just check. Here there is a chance that C will go into D and D will go into C. These are the chances. But why only C and D? So there can be many combinations. So out of these 4 envelopes, 2 can get disturbed. 2 can get disturbed. This is 4C2. Either you pick CD or BC or AD. Out of 4, you want to disturb 2 because you want to keep 2 correct and 2 incorrect. So that is what is the option here. So 4C2. 4C2 is nothing but 4 into 3 divided by 1 into 2. 2 ones are 2 twos are. So 4C2. This is a fact. This is a fact. You have to remember 4C2. You don't have to work in the examination hall. 4C2, remember it is 6. It is 6. So 6 ways we can see to it that 2 letters are going into their envelopes and other 2 are getting disturbed. This is what is the solution. So only 2 is correct. First one we cannot conclude because 1 gets disturbed. At least other one combination has to get disturbed. Okay. Next one. So now 7th one. What is the remainder? What is the remainder when this is divisible by 100? So whenever you are trying to divide by 100, seek for 5 and 2. So you need 2 5s and 2 2s to get 100. So look at the options where you have the multiples of 5. So here there is 1 5, here there is 1 5. Then you need 2 2s. 2 2s. See, in 96 you have 2 2s because 96 can be written as 16 into 6, or this 16 is nothing but 2 into 2 into 2 into 2, and again this 6 is 2 into 3. So you will have 2 2s easily and 2 5s easily. 2 2s and 2 5s. That means this whole expression can be divided by 100 perfectly. Then the remainder is 0. Remainder is 0. This is the simplest problem. In the examination hall, what do? We try to put this up in the numerator and this denominator. When the denominator is completely cancelled, if the denominator perfectly divides the numerator, then there is no headache. But if the denominator is not completely cancelled, then comes the headache in such problems. Then we have a different method. But for now, this one can be easily solved without any disturbance. What is the unit digit in the expression of this one? So here, for finding the last digit or the unit digit, we have one method. You have to keep the last digit of the, because we are going to deal only with the last digit when we want the last digit in this expression. So keep that 2 here. Then multiply these things. 9 into 7 into 5 into 3 into 1. 5 3s are 15, 15 7s are 105. 105 into 9 is 945. But this is a very big number. We have to divide this by 4 and get the remainder. So when I divide this 944 by 4, the remainder is 1. So your expression reduced to 2 to the power of 1. What is the value of 2 to the power of 1? 2. So your entire expression ends with 2. It ends with 2. This is what is the thing. So here what is the trick? You have to keep the last digit as it is and you have to divide the power by 4 and keep the remainder. So when this remainder is 0, you have to keep remainder as 4. Simple. Then see what you are getting at the last digit in this expression, and that will be the last digit of this entire expression. So it is 2. It is a straight away. When you know the method, you are there. Okay. A, B, C, D, E, F are 3-digit numbers such that they are distinct non-zero digits. Distinct non-zero digits means they are from 1 to 9. Now, they are asking ABC plus DEF is equal to 1, 1, 1, 1. A, B, C, D, F. And they are asking us what? Then what is the value of A plus B plus C plus D plus E plus F? So let us go from one to another. C plus F, and this C or F, they are from 1 to 9. 1 to 9. So minimum is 1. The other minimum is 2. So you want 1 here. So only when you think of 11 in the sum of this, that means C plus F should be equal to 11. This is a simple common sense. So carry will be 1. So when B plus E gives us something, we have to add 1 to it, then only we'll get 1 here. Again, we have to think of 11. So B plus E in this case is 10, because we are adding this carry to get 11. So B plus E is equal to 10. Now A plus D is also 10. A plus D is also 10. Now add all these things. So we get this expression. So 11 plus 10 plus 10 is 31. So A plus B plus C plus D plus E plus F is 31. This is a straight and simple problem, but you should not be worried initially. You should try. When you try, you will get the clue. So C plus F should be 11. Write that. B plus E should be 10 because we are getting the carry. A plus D is equal to 10 because we are getting the carry. So finally it is 31. D is the 3-digit number such that the ratio of the number to the sum of its digits is least. So this is one of the toughest problem. Toughest problem. D is a 3-digit number such that the ratio of the number itself, ratio of the number to the sum of its digits. That means sum of its digits. What is the difference between the digit at the hundreds place and the digit at the units place of D? For example, if I take this as 257, then 2 plus 5 plus 7 is 14. So this ratio has to be the least. D is a 3-digit number such that ratio of number to the sum of its is least. So we have to do that. For example, 999. What is the sum? 27. What about 100? It is 1. So if you take the ratio, it has to be the minimum. That means we have to try for the minimum number here. But with the maximum here. The sum should be maximum. So you have to think of something starting with 1 here. Because if you put 0 here, it is not a 3-digit number. You have to think of 1. Then if you want this sum as more, the other two have to be 9. So 199 and the sum is 19. 199 is to 19. This is what is the best possible, because it has to be 1. It cannot cross that one. Because we are trying for the minimum. And in this case, if I take this as 1, 0 and 9, this will be 10. 1, 1, 9, then it will be 11. If you go like this, finally the least value that I get for a ratio is 199 is to 19. In that case, like the difference between the digit at the hundredths place and the and the units place should be 8. Because I cannot use 0 at the first place. I cannot use 0 at the first place. Minimum is 1. Then take any other number. Biggest number is 9. So your answer has to be maximum 8. And that is what is there here. Maximum 8. So this is what is the answer. But if you go very technically into this concept, it takes a lot of time. And to teach you this concept, it might take around 15 minutes here in this particular case. So I will be giving some discount to such problems, because this is not the concept class. Wherever the concepts are simple and easily comprehensible, I am telling you. But these are the concepts which will need the deeper understanding. That is why I'm not doing, but I'm straight away giving you the answer. Why? First digit has to be 1, the other digit has to be 9. That's it. That is where we'll get the least ratio. And these are not the classical problems. These are like once in a while they come. Okay, next question. This is related to passage. Let me skip those passages. Yeah, 14th question. 14th question. 3 of the positive integers. 3 of the positive integers PQRST are even and 2 of them are odd. 3 of them are even and 2 of them are odd. Consider the following statements. Okay, P plus Q plus R minus S minus T is definitely even. They are telling definitely even. See, there are 3 even numbers. 3 even numbers are there and 2 odd numbers are there. So I will be more interested in this 2 odd numbers. Whatever that you do with the odd numbers, let's say odd plus odd, odd minus odd, okay, or minus odd, or minus odd plus odd. In all the possible operations, you assign any sign to odd numbers, you do anything, plus, minus, whatever that you want to do, your answer will be even. Your answer will be even. You assign the odd value to any of these 5 variables. With these 2 odd variables, with these 2 odd numbers, you will get even result. Now, I am left with 3 even numbers. So 3 numbers, even numbers. Again, do anything with 3 even numbers. Even, you do anything with 2 even numbers. When I say anything, it is plus or minus. Do anything with 2 even numbers, you will get the even result. Do anything with 2 odd numbers, you will get the same result. So here, 2 odd numbers will get us the even result. 3 even numbers will get us the even result. So here, this is definitely even. This is definitely even. Coming to this point, like 3 of them are odd. Sorry, 3 of them are even and 2 of them are odd. 2 of them are odd. But we are subtracting here only in one case. Other cases we are adding. Okay. What would happen? Let me take the even values for all these things. Even values. So even into 2, even number, and even number. Okay, this is odd, this is odd. Again, odd plus odd. Odd plus odd will get us what? The result even. So when they are telling definitely odd, even if I disprove it once, like that is wrong. Here what did I do? I took the even values for P, R, S. Then this is even, and this is even. Other 2 are odd. So Q plus T. 2 odd numbers when you are making the sum. Result is even. So in this case, I am telling it is even. So definitely it is not odd. All the times it is not odd. So it can be even also. So even once if I prove that the result can be even, this statement becomes wrong. So here 1 only is the answer. So please be aware of the mechanisms of this odd and even numbers. So whenever you add or subtract the odd numbers or even numbers or odd from even from odd, and the multiplication of them, please make a chart and keep it with you. Odd plus even plus odd minus even minus even, odd minus even. Please make a chart. For similarly for product also, that is for multiplication, odd into even into odd into odd, and even into even. Please make a chart and keep it with you, because such questions are coming. Even in the 2024 paper, we saw one problem pertaining to odd and even. So please be careful there. Okay, again odd even. But here they have given can be. So can be. Even if we prove this statement once, that's more than enough to conclude that that is right. Okay. In the previous case, is definitely is and are, they are definite. They are definite. Even if you disprove once, that statement is wrong. Here, if you prove at least once, you are correct. You have to prove at least once. So here, consider the following respect of prime numbers P and composite number C. So whenever you think of prime number P, you can think of 2 also and other prime numbers like 3, 5, 7. So whatever the difference that makes to this prime number is 2. So this is what UPSC is checking, whether you know the peculiar character of this 2 or not. They are checking that one. So 2 is that peculiar prime number which will disturb us or which will give us very special results. That is what we have to be careful of. Then this is a composite number. And when we say composite number, it is not just even number. Okay, it starts from 4. 4 is composite, 6 is composite, 8 is composite, 9 is composite. That means it is not a prime. It is not a prime. Okay. Then next one is 10, 12 like this. So even odd numbers are there when it comes to composite numbers. They are asking this can be even. This can be even. When you can prove that this is even, definitely this part has to be even. This part has to be even and this part can be either odd or even. We have to just go case by case. So here P is something that is a prime number and C is a composite number. Let's say P is 11 and this composite number, let's say this is I would take 9. Then 11 minus 9. So this is 20 and this is 2. So this is 10. This can be even. Even if you prove once that it is even, this statement is right. It can be even. 2P plus C can be odd. So when I want odd, this is anyways even number because it is multiplied by 2. This particular number will be even. Just think of a composite number which is odd. Let's say 9 is odd. 9 is odd. So even this is correct. P into C can be odd. Yeah. When you want the odd product, both the numbers what you are multiplying here should be odd. So P is equal to 3. Then composite is 9. 3 into 9 is equal to 27, which is odd. So all 3 statements are correct. So when they say can be, maybe, they are simple. They are simple. You have to prove only once. That's more than enough. But when they tell is, definitely, certainly, so there you have to prove that this is wrong at least once. If you prove that is wrong at least once, that entire statement is wrong. So when you are coming up with that certain definite thing, you have to try to disprove it or you have to try to make it wrong. But when they say can be, maybe, you have to try to get it right. Get it right. Okay. Next question. A 3-digit number ABC on multiplication with D. Yeah, this is bit mind provoking question. A 3-digit number ABC on multiplication with D will get us the result 37DD. It gets us the result 37DD, where ABCD are different non-zero digits. So you have to be very careful of this because time and again I am saying this non-zero digit, distinct digit. Non-zero means 1 to 9. 1 to 9. When we say digit, one digit, so it is 1 to 9. What is the value of A plus B plus C? This is what we have to find out. See, if you go on substituting some value for A, B, C, there is no end for it. It will consume a lot of time. But if you think of just D, 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 if you just think of D, 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 then you might get the solution very quickly because you are assuming one variable, 1, and you are trying to find the answer. But assuming A, B, C and finding the answer would be difficult. So let us check. I will put 1 for this D. So when D is equal to 1. So it will become 3711 by 1. So answer is 3711. So this is a 4-digit number. So this is wrong. When D is equal to 2. 3722 divided by 2. Again, it will be a 4-digit number. That is 1861. That is also wrong. Then when D is equal to 3, 3733 divided by 3. Actually, this is not a number which is divisible by 3 because 3 plus 7 is 10. 10 plus 3 plus 3, 16. Not divisible by 3. Then when this is 4, 3744 divided by 4. Yeah, we can divide. We'll get a 3-digit number. 4 9s are 36. Then 4 3s are 12 and 4 6s are 936. 936. So D value will be equal to 4. D value will be equal to 4. Even when you put 5, it will be 3755 divided by 5. So what will be the answer? 5 7s are, then 5 5s are, then 5 1s are. 3755 divided by 5. So 5 7s are 35, then 5 2s are, then 5 1s are. Then here when I take this as 5, and the answer is 751. So B has to be 5, but they are telling these are different non-zero digits, so I cannot take like that. So even when D is equal to 6, 3766 divided by 6, no, it is not divisible by 6. 7, 3777 divided by 7. So we can check 7 5s are 35, 7 3s are 21. No, it is not divisible. 8, 3788 divided by 8. So can we divide? No, this is not divisible by 8 actually. 8 4s are 32, 8 7s are 56. Then it is not divisible by 3799 divided by 9. Yeah, this is not divisible by 9. So finally the answer is 4. So when answer is 4, the value of A, B and C are 9 and 3 and 6 respectively. So 9 plus 3 plus 6 is 18. 9 plus 3 plus 6 is 18. Yeah, this is a bit complicated because it asks you to assume so many things. So if you assume only D and cross check, you will get the answer. Next one, 17th question. For any choices of values of x, y, z, the 6-digit number of the form xyz is divisible by. See, whenever you write something of the form xyz, I'll give you an example, 247, 247. So this is a pattern. This number is divisible by 1001. So when you multiply this 247 to this 1001, you will get the answer 247247. You can try. So for me, any number of this format is divisible by 1001. Any number of that format is divisible by 1001, and that is also divisible by x, y and z. That is also divisible by x, y and xyz. The number is xyz, not individually. Number is xyz. In this case, I am more interested in finding the factors of 1001. I am more interested in finding the factors of 1001. So 1001, try to divide this by any other number. 2 not possible, 3 not possible, 5 not possible, maybe 7 I'll try. So 7 1s are 7, then 7 4s are 28, then 7 3s are 143. 143 looks like a known number. So this is 7 into 11 into 13. So the factors of this number, 1 is 7, 1 is 11 and 1 is 13, and also this number xyz. So all these are the factors of this number. So 7, 11, 13. So yes, we have got 7, 11, 13. But how did I reach to that 1001? Yeah, that requires bit of like pattern finding. For example, if a number is of form xy, that is divisible by 101. If the number is of form y, it is divisible by 111. In this case, the number is of form xyz. So 1, 2 zeros and 1. So you can try that one. Because 001 is what is important here. 001 into some 3-digit number will give the same 3-digit number. Then other one on the thousandth place, it will again give the value of xyz. That is what is the observation, and that doesn't come overnight. And by teaching, that doesn't come. It will come by observation. So you should have such observation. Here, simple thing, this is divisible by 1001. And the factors of 1001 are 7, 11 and 13. Okay. 125 identical cubes arranged in the form of a cubical block. Simple. Whenever you come across this cube, 125's cube root is equal to 5. That means it is a cube of a shape so 25 in one layer, like that, 5 layers, like that will come. So here this is a 5 cross 5 cross 5. The cube is 5 cross 5 cross 5. How many cubes are surrounded by other cubes from each side? 125 identical cubes are arranged in the form of a cubical block. How many cubes are surrounded by other cubes from each side? From each side, how many cubes are surrounded by other cubes from each side? That means indirectly they are asking the cubes which are not visible from outside. They are asking for the cubes which are completely hidden inside from all the sides. From all the sides. There are 6 faces to it. 6 faces to it. Top, bottom, left, right, front and back. 6 layers are there. So if you remove those 6 layers, top, bottom, front. So if you remove 2 layers in each dimension, you will be remaining with 3 layers in each dimension. You will be remaining with 3 layers in each dimension. That is 3 into 3 into 3. 3 into 3 into 3. That is 27. That is 27. So this is what they are asking. Usually in cubes, what will come? Like the bigger cube is taken and painted from outside and it is cut into smaller cubes. So they will ask the questions like how many cubes are painted in 3 faces, how many cubes are painted in 2 faces, 1 face and no face. So here they are indirectly asking like which all are those cubes which are surrounded by other cubes in all dimensions. So we are looking for that core area which is inside. That is 3 cross 3 cross 3. How many distinct 8-digit numbers can be formed by rearranging the digits of 1, 1, 2, 2, 3, 3, 4, 4 such that odd digits occupy odd positions and even digits occupy even positions. Okay. So 1, 1, 2, 2, 3, 3, 4, 4. So here they are asking odd digits occupy odd positions and even digits occupy even positions. Okay. So odd positions, even positions are nothing but this is odd position, this is odd position, this is first, third, fifth and seventh. So here odd number should come. Let's say 1, 1, 3, 3. That means for odd numbers, we have 4 places. We have 4 places for odd numbers. We can arrange them in their places the way, for example, those odd numbers, there are 4 odd numbers. Those 4 odd numbers can be arranged in 4 factorial ways. 4 places are there, 4 numbers are there. They can be arranged in 4 factorial. But this 1, 1 and 3, 3, 1, 1, 3, 3 are repeating twice. So 1 is repeating twice and 3 is repeating twice. So this is the calculation. This is for odd numbers in odd places. Similar thing for even numbers also. Even numbers are 4. So 4 factorial, but they are repeating. 2 is repeating twice and 4 is repeating twice. So this is what is the calculation for the even numbers. So when you multiply these two terms, you will get the answer. So 4 factorial is 24 into 24 divided by this 2 into 2 into 2 into 2. So 4 6 are 4 6 are 6 6 are 36. So 36 ways are there when double 1, double 2, double 3, double 4, the digits of this are arranged in such a way that odd numbers take odd places and even number take even places. This is just like a repetition of the digits or repetition of the alphabet in a word, but their positions are fixed. For odd numbers, odd places are fixed, and for even number, even places are fixed. Next one. ABC working independently can do a piece of work in 8, 16 and 12 days respectively. A alone works on Monday, B alone works on Tuesday, C alone works on Wednesday. Okay. A alone again works on Thursday and so on. So they are working on different days. So first the work is started by A on Monday, then B, then C, and so on. So we have to see how much of the work is done on everyday basis. So first day he will finish 1 by 8 of the work. B will finish 1 by 16 of the work. And C will finish 1 by 12 of the work. And this cycle is going to repeat. This cycle is going to repeat. So please add how much of the work is done in 3 days. So 1 by 8 plus 1 by 16 plus 1 by 12. So here the LCM is 48. So 8 6 are, 16 3 are, and 12 4 are. So this is 13 by 48. But work is one work. So 13 by 48 is finished in 3 days. So take the reciprocal. Such how many cycles are required? So take the reciprocal, you will get the number of cycles. So 3 full cycles, 13 3s are, 13 3s are you need. 13 3s are, so 3 full working days you need. Then how much of the work will be remaining? That we will see. 13 by 48 of the work is done in one cycle. You need such 3 cycles. So 39 by 48 of the work is done in 3 cycles. 3 cycles means 9 days. Because one cycle is of 3 days here. Such 3 cycles are required. So remaining work is 1 minus 39 by 48, that is 9 by 48 of the work is remaining. 9 by 48 of the work is remaining, that is close to 3 by 16. 3 3s are, 3 16s are. 3 by 16 of the work is remaining. Now, after 9 days, after 3 cycles, again A is going to come. Again A is going to come. How much of the work is remaining? 3 by 16 of the work is remaining. How much he will do? He will do only 1 by 8 because it is his capacity. So 3 by 16 minus 1 by 8. 16 is the LCM. So 3 minus 8 2s are. So 1 2s are. So 1 by 16 of the work is remaining. Now who will come on the next day? B. B will come on the next day and 1 by 16 of the work is remaining and he will finish this work. So 9 days, 3 cycles, 9 days are done. Then on 10th day, A will come and on 11th day, B will come. So they would require 11 days to finish the work and they are starting on Monday. So Monday to Monday, 7 days are done. So Sunday is done. So again Monday 8, Tuesday 9, Wednesday 10, then Thursday 11. They are going to finish the work on Thursday. Look, the work will be finished on Thursday. Correct. The work will be finished in 10 days. No. Work will be finished in 11 days. So such problems are coming regularly in time and work, where you have to see in one cycle how much work is done and how many cycles are required. How many cycles means how many days. How much of the work is remaining. Again, who will take up the work in the remaining days. Okay, so that way you have to see when the work will be finished. In this case, like on 10th day A will come, on 11th day B will come again, and they will take total 11 days and the work will be finished on Thursday if they have begun the work on Monday. Next are passages. So here this is kind of a pattern finding again. 7, 9, 10 is equal to 8. 9 plus 11, I mean, we have to put some symbol there, is equal to 5. Then 10, some symbol is equal to 13. And what is the value of 23? This symbol 15. See, uh, yes, this is more kind of a logical reasoning question, So here, what they are doing, here, pure maths will not come into play. Because I am going to show you. See, finally they are arriving at a number which is lesser than the given numbers. So whenever you do addition, you will get a bigger number. Whenever you do a multiplication, you will get a bigger number. But when you take the difference, but whose difference from where? So that is the question. But simplest thing for any human being is to do the sum. Do the sum and check what is there. 7 plus 9 plus 10. This is 26. But this is 8. Just check 2 plus 6 is equal to 8. This is just matter of chance. This is not a rocket science. Just we are checking whether it suits or not. Now, 9 plus 11 plus 30. 9 plus 11 is 20. 20 plus 30 is 50. 5 plus 0 is 5. 11 plus 17 plus 21. So 11 plus 17 is 21. 28. 28 plus 21 is 49. 4 plus 9 is 13. Yeah, this holds good, but this is just a matter of chance. So what you have to do in such cases, try with addition, try with some addition and subtraction, try with multiplication and do. And this is kind of, like a jugaad kind of thing. Like it is not maths. Okay. So adding the digits, it is not maths. So it is just some logic. So when they are asking you some logic, you have to do hit and trial. Okay, hit and trial. So if that holds good, that's fine. Otherwise, like you should not waste more than 1 minute in such questions. Okay, so in this case, 23 plus 4 is 27. 27 plus 15 is 42. 4 plus 2 is equal to 6. 4 plus 2 is equal to 6. Okay, next problem. Let x be a positive integer such that 7x plus 96 is divisible by x. 7x plus 96 is divisible by x. Let x be the positive integer. That is from 1 to any other number. Okay. How many values of x are possible? See, we are trying to divide this. Let x be a positive integer such that 7x plus 96 is divisible by x, and x is a positive integer. See, in this case, if I split this one, it will be like 7x divided by x plus 96 by x. And you want a positive integer because you are trying to divide this perfectly. X get cancelled, but you need to divide this 96 by x perfectly. Then you have to find the factors of 96. Simple. You have to find out the factors of 96. The very simple factors or the natural factors are 1 and 96 themselves. Then if you divide by 2, 48 is also a factor. If you divide by 3, like 32 is also a factor. If you divide by 4, 24 is also a factor. If you divide by 6, 16 is also a factor. If you divide by 8, 12 is also a factor. So totally, if you count 6 here, there are 12 factors of 96. So x, when you divide by this 96 by x, so this x can take 12 values right from 1 to 96 in this way. Okay. Otherwise, 96, if you express like 2 to the power of 5, that is 32, into 3 to the power of 1. In such cases, what you have to do, take this 5 and add 1, and take this 1 and add 1. So here 6, here 2. 6 into 2 is equal to 12. So there are 12 factors. This is a method. This is called as prime factorization. You have to do, you have to simplify this to the powers of a prime number, then add 1 to each power, then multiply them. Add 1 to each power and multiply them. So you will get the number of factors for that number. So in this case, 12. PQRS are distinct single digit positive numbers. So suddenly you have to think of 1 to 9. Then what is the greatest value of P plus Q plus R plus S? So when you want the product of this, you will tend to choose the bigger number for sure, 9. After 9, you will choose 8. Then you will choose 7 and 6. But where to put what? So first I'll try to write 9 plus 8, bigger number, then comes 7 plus 6. So this is 17 into 13. 13 sevens are 91, 13 ones are 13, 221. The answer is 221. But if you think that this is the highest possible number that we can get, no, we are wrong. In that case, what you have to do, you have to try to equate these terms. These terms should be same. So in that case, 9 plus 6 and 7 plus 8 will give us 15 into 15. Try to hit the same number here rather than the different numbers. Try to hit the same number to get the square value perfectly. 15 into 15 is 225. In this case, 225 is the right answer. So here, what we are trying to learn, when you want to get the product of two numbers, let those numbers be as close as possible. As close as possible. 17 and 13. Yeah, they are closer, but not. But this is the closest, like 15 into 15. So whenever you look for a square, you will get the maximum area, maximum area. So when you think of a square or a rectangle, with the same perimeter, here also the perimeter is what? 17 on one side, 13 on other side. 17 plus 13, then twice. So you try to get the square area. So with the same perimeter, if you take a square area, you will get more area. That is square centimeter or square inch or square kilometer, you will get more. So try to get those numbers as close as possible. Then only you are going to get the maximum product. Next. A number n is formed by writing 9 for 99 times. N is formed by writing 9 for 99 times. So totally I am writing it for 99 times. So 99 nines are there. What is the remainder if n is divided by 13? Here we are trying to divide by 13. We are trying to divide by 13. If a number is formed by writing 9 for 99 times, what is the remainder if n is divided by 13? See, similar problem we have done. For example, this is of the form. 1 1 1 1 1 1 1 1 1 1. No matter how many times, and we are trying to divide this by 13. So initially we had done one thing, that is 1 1 1 1 1 or anything of the form xyz xyz, anything of the form xyz xyz, and these xyz can be same numbers, x and y and z can be same numbers. I'll take them as 1 1 1 1 1 1. So this number xyz or 111 is definitely divisible by 1001. This is definitely divisible by 1001. And we have seen the factors of 1001 as 7, 11 and 13. 7, 11 and 13. So this number is divisible by 13 for sure. This number is divisible by 13 for sure. That means what? That means 6 ones are divisible by 13 perfectly. Similarly, 6 nines are divisible by 13 perfectly. Then if you take the sets of these 6 nines, 12 nines, 18 nines, so multiples of 6. So totally 99 nines are there. So first 96 nines will be of the form 9999999. Okay, another 6 nines. Like that, many 6 nines will come. So all such things for 96 times will be perfectly divisible by 13. Will be perfectly divisible by 13. Now, 96 nines are over. 96 nines are over. When we divide that by 13, the remainder will be 0, but other 3 nines are remaining because we are having 99 nines. So what we are remaining with is last 999. We are remaining with last 3 nines because 96 nines are divisible by 13 because I have given you the proof. XYZ is divisible by 13. 111 divisible by 13. 999 divisible by 13. So 6 nines or 6 any numbers divisible by 13. So like that, 96 nines will be divisible by 13. Remaining are 3 nines, and if I divide this by 13, 13 sevens are 91. Then 8 is remaining, 89. Then 13 6 are 78. So remainder will be 11. In this case, the remainder is 11. This is not easy problem. This is not easy problem. 99 nines. When you think of that, you will get terrified. You will get terrorized by this question. So it is depending on a pattern. I told you. See, 111 is a pattern because it is 3 into 37. 1001 is a pattern. This is 7 into 11 into 13. Like this, you have to think of few patterns. You have to think of few patterns. 101, it's a prime number. 11 is a prime number. But 111 is divisible by 3 and 37. Remember. Then 1001 is divisible by 7 into 11 into 13. Please remember these things. So in this case, the answer is 11. Each digit of a 9-digit number is 1. Okay, similar problems. Each digit of a 9-digit number is 1. So I am writing 9 times 1. 9 times 1. 111, 111, 111. It is multiplied by itself. Again, I'll write 111, 111 and 111. Okay. How do you do simply? Take the first number and multiply. What is the result? 111, 111 and 111. Next, take 1, again multiply. What is the result? 111, 111, 111. So it will just keep floating like this. So now plus plus. So what will be your number here? Like this. But if you go on calculating, this will be 1. This will be 2. So similarly, this will be 3, this will be 4, this will be 5, 6, 7, 8, 9 times, then again it will go on decreasing. 8, 7, 6, 5, 4, 3, 2, 1. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. So this is how the number looks like. But they are asking what is the sum of the resultant. Sum of the resultant. So you have to add this 1 to 8. When you want to add first 8 numbers, this is simple. N into n plus 1 by 2. So 2 ones are 2 fours are. This is 36. 1 to 8 again here. That is also 36. 36 plus 9. So 72 plus 9 is 81. The answer is 81. Or some small clue I will give you. 9 ones. This is divisible by 9. 9 ones divisible by 9. Number divisible by 9. Number divisible by 9. When you make the product, again that resultant will be divisible by 9. And when a number is divisible by 9, add the digits. You will get something divisible by 9. So that is what is among the given answer. Only this answer is divisible by 9. Simple. But it takes a lot of mastery. It takes a lot of mastery. Many years of experience. You cannot just guess like that. Okay. But when you have the conviction that your method is correct and your clues are correct, then you can mark that. But if you are not at that level, don't guess the answer. Here we are not guessing. We are applying the logic. But this is what is the school method that we have done. But the number is scary a bit. But when you get the pattern, the life becomes simpler. Next question. What is the sum of all digits which appear in all the integers from 10 to 100? From 10 to 100. Here I had told you one particular thing, that is from 1 to 100. From 1 to 100, each of the digits comes 20 times. Each of the digits, whether it is 1, 2, 3, 4, 5, 6, 7, 8, 9, it comes 20 times. It comes 20 times. But basically, that is from 00 to 99. From 00 to 99, forget this number for right now. So for 00 to 99, all the numbers will be written 20 times. That is 1 times 20. Sorry, 20 times 1, then 20 times 2, like this, 20 times 9. So they are asking the sum of all the digits. Sum of all the digits. So 20 times 1, 20 times 2, like that up to 20 times 9. So rather than adding them like this, what I'll do, I'll add them first. 1 to 9. 1 to 9, what is the sum? N into n plus 1 by 2. 9 into 10 by 2. 2 ones are, 2 fives are. This is 45. But each of them is used 20 times. So 45 into 20, 900 times. Or the total sum is 900. Total sum is 900. But that is for 00 to 99. That is for 00 to 99. But I want for 100 also. And I want to subtract 1 to 9. Similarly, from 00 to 99, what we have done, like that from 0 to 9, each digit is used once. Each digit, that is 1 to 9, is used once. That means 1, 2, 3, up to 9. What is the sum of this? So 1 to 9, what is the sum? 9 into 10 by 2. N into n plus 1 by 2. 2 ones are, 2 fives are, 45. I don't want this because 00 to 99 I have calculated, this is 900. In that I want to subtract this. That is for 0 to 9. So if I subtract 45 here, I'll get the answer as 855. This is the sum of all the digits from 10 to 99. 10 to 99, the sum of all the digits is 855. But I need 100 also. I need 100 also. So if I add 1 for this 100, 1 plus 0 plus 0, 100, the sum is 856. This is not easy. This is not that easy unless you have this fact that 00 to 99, each of the digits from 1 to 9 is used 20 times. Is used 20 times. From 0 to 9, each of the digit is used once. Like that, if you write 000 to 999, you will use each of the digits 300 times. 0 to 9, each digit one time. 0 to 9, each digit one time. 00 to 99, each digit 20 times. 000 to 999, each digit is used for 300 times. Note it down. 0 to 9, each digit is used once. 00 to 99, each digit is used 20 times. And 000 to 999, each digit is used 300 times. Please note that down. And when I say each digit, 1 to 9, not 0. Not 0. 0 will be less in number. Okay. Because the zeros that we write in the beginning, they don't have value. So we don't consider them. So 1 to 9 will be used 1 times. That is in single digit number. In double digit number. So I'm not telling double digit number. 00 to 99, each digit is used 20 times. 000 to 999, each digit is used 300 times. Please note that down. In that case, 856 is the answer. Okay. Next question. ABCD is a square. A, B, C, D. So whenever you name this square, you have to name cyclically. A, B, C, D or clockwise. 1 point on each of AB and CD, and 2 distinct points on BC on each of BC and DA are chosen. How many distinct triangles can be drawn using this one? How many distinct triangles can be drawn? In this case, 6 points are there. And to draw any triangle, you need 3 points. You need 3 points. So this is straight away 6C3. 6C3 is nothing but 6 into 5 into 4 divided by 3 into 2 into 1. 3 ones are 3 twos are 2 ones are 2 ones are. So 20. 5 into 4 is 20. So this is like whenever you want to construct a triangle out of given points, that is straight away NC3. Here 6 points are given. But when you are constructing the triangles, be careful about the collinear points also. Collinear points. Here none of them are collinear. What are collinear points? The points which lie on the same line. And when more than 2 points lie on the same line, they are called as collinear points. Okay, you have to be careful about that. This is a straight question. A box contains 14 black balls, 20 blue balls. A box contains 14 black balls, 20 blue balls and 28 yellow balls. This is similar to what we have done with the pair of shoes. So similar problem is this. So there are 5 colors: black, blue, green, yellow, red and white. There are 6 colors. So totally how many balls? 14, 20, 26, 28, 38 and 54. Okay. The smallest number n such that any n balls drawn from the box randomly must contain one full group of at least one color. One full group of at least one color. So when you draw, you should see to it that one full group is there. Which group we don't know. So again here you have to think from the worst scenario. Worst scenario, that means you want to get a group but it is not happening. That means what is happening? At least one ball is remaining in the box of that color. At least one ball is remaining. So you are so unlucky that whenever you draw, you are not seeing like the full group is there. When that can happen? At least one ball in each color is remaining in the box. So how many colors are there? So 6 colors are there. Of each color, one ball is remaining. That means 6 balls are remaining in the box. You have removed all other balls, but 6 are remaining in the box and they are troubling you because one ball of each color is remaining in the box. That is why it is not allowing to meet the condition that one group of color or each ball of one group. So either it is red or black or whatever, but 6 are remaining. So total is how much? 14 plus 20, 34 plus 26, 60, 60 plus 28, 88, 88 plus 38, 126 plus 54, 180 balls are there. But 6 are remaining there. That means 174 balls are drawn and your groups are not complete. Like at least one group is not complete. So you draw the next ball, at least one group is going to be full. So in 175th draw, you will make at least one group. So that is what is the calculation here, 175. The smallest number m such that any m balls are drawn from the box randomly must contain at least one ball of each color. Here, one group, full group. But here they are asking one ball of each color. One ball of each color. Here the worst case, what can happen? What can happen? Out of 6 colors, 5 colors are out. Out of 6 colors, 5 colors are out. But that 6th color is not coming. So we are so unlucky that 5 colors have come out, but the 6th color is not coming. So what to do? That means all the balls of that color is remaining. All the balls of that color is remaining in the box. But here Which color is that? Already you are unlucky. Already you are unlucky that one group is not coming out at all. And which group is that? The smallest group. Smallest group is troubling you. Even you can think of the biggest group, but you are not that unlucky. You are moderately unlucky or moderately lucky. But you are not getting one group or one ball of that group at all, and that too a smaller group. So that will be more irritating. That will be more irritating. It is just like, like the batsman at the position 8, 9, 10, 11 are troubling you. So they are not getting out. So that is what is troubling. So here the smallest group is this 14. Smallest group is 14. Out of 180 balls, if you subtract this 14, like 166. 166. 166 balls are out. That means these balls are out. But this is not out. That is why you are not getting, like each color ball. So now, after this 166 draw, the 167th draw will get you one ball of that group and your condition is met. So that is 167. So both are correct. This is like mind-boggling problem. So you have to practice these problems again and again. And what is the clue here? You have to think from the worst case. You are the most unluckiest and the odds are against you. That is why this is happening. This is how you have to think and do this problem. Next. This is simple. 0 is written as chur. 0 is written as chur. So what is the clue? See, Z is 26th and this is 3. So when you go 3 plus 3 places front, so you will get C. E is 5, H is 8. So plus 3. R is 18, U is 21. So plus 3. So we are adding plus 3 all that. Then how is player written as? Player. So P plus 3, PQRS. Then L plus 3, LMNO. Then A, B, C, D, Y, Z, A, B. Then E, F, G, H, R, S, T, U, S, O, D, B, H, U. This is the answer. This is straight. Just you have to find the relation and apply this here. That's it. Then next question. A is older than B. A is older than B. C and D are of the same age. E is the youngest. F is younger than D. F is older than D. What they are asking? How many statements given above are required to determine the oldest person? I want the oldest person. See here what they have given. Only 2, only 3, only 4, all 5. This is very tough to decipher. There is no shortcut like that. See what is happening here. A is older than B. The relation between A and B is given here. C and D are of the same age. Again, C and D's, A is older than B. Then C is equal to D. E is the youngest. So this is one, like a total, concludable thing that we have. E is the youngest. F is younger than D. F is younger than D. F is older than A. And they are asking the eldest. They are asking the oldest or the eldest. See, here E is there. See, AB, where A is connected? Yes, A is connected there. Then we can establish the relation between F, A, B. Then F is connected with D. So we can explain the relation between these 4. Then D is related to C. Then E is related. E is the youngest. So when you read everything, then only you will get the answer all 5. But this is easier problem. You can get the answer straight away, but don't take risk in such questions. Whenever they come, how many statements? If they ask which of the following is true or whether statement 1 or statement 2 is right or wrong, that is easy. But how many of the statements? Don't take risk in this one. This is easy because you need all 5 statements here to connect each other. Otherwise, in such questions, there will be a tough scenarios. Now, question number 39. Consider the following A, B, C, D, E in a family. There are 5 members. Question is, what is the relation of E to B? What is the relation of E to B? I need E to B. Okay. Here again, there are more than 3. There are 4 statements here. Now, A and B are married couple. So, A and B are married couple. We don't know who is husband and who is wife. D is the father of C. I don't have any sense here. E is son of D. So these two can be connected. D is father of C. And E is D's son. E is D's son. Then A and C are sisters. A and C are sisters. So D is father. He has 3 children. And the husband of this A is B. So this is what I can get. But they are asking what is the relationship between E to B. E is son, A is daughter, B is the husband of daughter. So husband of a sister is brother-in-law. So relation of E to B. So E is brother-in-law of B. E is brother-in-law of B. But to conclude this one, how many statements are required? Yeah, you should know that the marriage happened between A and B. Then also you need E. E is D's son. E is D's son. But A and B are connected here. E and D are connected here. But there is no direct relation between any of them. I need to connect E to B. Now I know something about E, that is D. I know something about B, that is A. But where is A? A is connected to C. Then C is connected to D. C is connected to D. So all 4 statements are required here. Nothing is extra. Nothing is extra. All 4 statements are required here. So all 4 statements are required. So here in such questions, be careful, because there can be more than one, way of dealing with it. So be careful in that. But luckily these 2 questions are like solvable and easy. The last question that I'm seeing, because we'll be ending at 40. In the next video, we'll do another 40. Okay, choose the group which is different from the others. Again, here, just you have to apply your logic and just you have to see whether it clicks or not. Okay. 17, 37, 47 and 97. They are in increasing order. And they all are prime numbers. You can check. For that, you have to have a very good knowledge about prime numbers. Then 31, 41, 53 and 67. They are also prime numbers. You can cross check. They are increasing. Then 71, 73, 79 and 83. Even they are prime numbers. And they are increasing. 83, 89, 91 and 97. Problem is 91 is nothing but 13 sevens are. So that is not a group of prime numbers or in the increasing order of the prime numbers. So this is the only culprit that we can get. So here this is like not belonging to the group, odd man out. But here you should have clear-cut knowledge of prime numbers. And how do you know that? When you practice the tables, then only you will get to know these numbers except this will not come in any tables up to 20. So that is the clue, or even up to 30 you can try. So this is just a matter of chance. But if you know the tables up to 20, such questions will get very easier. So 40 questions in 2023 CSAT paper we have solved. So in the next session, we'll be completing other 40 questions. Till then, hang with us. All the best. Thank you so much.